Okay, welcome back. I had some technical difficulties, and video had to stop in the middle yesterday. So this is part two. I was informed that I might look different because I'm wearing a different shirt. So I just want to let everyone know that yes, this is a different day doing the same end of the video. I had finished with the work that had to do with subtracting a fraction from a whole number, and I had left that off. So I want to work on that right away. And here comes that question. There's a lot of things going on with that question that I would like to kind of talk about from like a theoretical standpoint, and then from the actual kind of standpoint that we had. Okay. Now, I also recognize that we can have issues with adding our fractions together, and that would be what happened on this page, where we ended up having something that was bigger, which meant it was an improper fraction and we had to change it to a mixed numeral. So the opposite of that would be an example that looks like this. And I apologize if I am rehashing the same video, but I don't see that I did this with you, but I will give it a try. So first of all, this is the one question we haven't talked about. And here's another question that we might end up talking about at some point. So this is a subtraction question between two mixed numbers. Shouldn't be any different than any other question we have with mixed numbers, except for the fact that if I do what I had promoted you doing here, and keeping the big 6, and keeping the big 4, something happens that you might notice. Now, I did everything right. I multiplied by 7 and 7, because that gets me to 56. I multiplied by 8 and 8, because that gets me to 56. And I have my 21 and my 40. So the issue here, if you didn't notice, is that 21 is not big enough to subtract 40. And so there are occasions that this works out or goes in this direction that you have to figure out what to do because of that. So what you're going to do in this situation is what we call borrow from the 6 and make it a 5. And then you could actually add 56 to that, because when you borrow one whole away from the 6 to make it a 5, you're adding a whole amount, which is your 56. Now that turns into 77 over 56, which you can certainly subtract 40, or subtract 40 from. And you will end up with 1 and 37, 56. Now, one of the other things you can do, if you find yourself in this predicament where you are recognizing that the number on the top is not big enough, you could jump back to one of the things that we talked about before, which would be to change these to improper fractions and then just go through the motions of getting your denominators and everything like that. So you'd be multiplying by 7 and 7, you'd be multiplying by 8 and 8, and you would end up with 357 over 56, and you'd be left with 264, I believe, over 56. And that certainly is subtractable. And so when you do that, you should still end up with the same answer. But it's just going to take you a different direction. So look out for that when you're doing your subtraction of mixed numbers. Sometimes it turns out that the number on the top fraction is not enough, which could lead you to do one of two things: borrow or do what I just did. So take some time to rewind that part of the video if you need it. Okay? Now, here's the other question that is important for us to look at. It says 10 minus 3 ninths. Okay? Theoretically speaking, you can take 10. This is the way I think about it. Let's say you had some sort of a pack of 9 cans of some sort, or 9 bottles, or 9 something, and you had 10 full packs, and someone came along and they say wanted just 3 bottles. What you would do was you would have to break open one of your full packs of 9 and have those 9 loose bottles lying around. And then you're going to subtract the 3 9s from that. So what I'm trying to say is you can look at this theoretically of saying, well, I have my full packs here. I've broken my full packs down by one, leaving me some loose bottles or cans or whatever of whatever I have, and then I can take that away. And this turns out to be this, which can be reduced to this. Another way of thinking about this goes with this one. Let's say you have 12 full packs of whatever, and you have someone who wants to borrow or take from you 5 full packs and 2 single parts. That means you have some sort of a pack of 5. So you got 5 things in a pack. So when you give them the full 5 packs, that's fine. But then you got to break open a pack in order to give them the pieces. So that changes this to 11, and you have 5 parts that are kind of hanging around. And then when you do that, you end up with the 6 and 3/5 because you had those 5 things hanging around and you gave away 2 of those things and you ended up with 6. Okay? So that's another way of looking at that. If theoretically speaking, you want to think about how the borrowing thing works from the previous example. Here's a last way of looking at this same one. I can just write this as 12 over 1, and I can change my 5 and 2/5 to 27 over 5. Then I can multiply by 5 and 5, and I will get 60 over 5 and 27 over 5, which turns out to be 33 over 5, which turns into 6 and 3/5. So you don't have to do the borrowing way if you don't want to. It does come in handy in certain situations, specifically on the MyMathLab. Okay, that is it for fractions on MyMathLab. And looking at how that worked out, that was Unit 2. Unit 2 is one part of our work for this week because we also had Unit 3. So there's a piece of the puzzle here that was put out for everybody to see on Unit 3, and I would like to go over that with you for the next few minutes to finish off Part 2 of our video. So I'm going to write some numbers in to the spots here, or words, excuse me. Round to the nearest tenth. Round to the nearest hundredth. Round to the nearest thousandth. Round to the nearest 10,000th. Round to the nearest 100,000th. All have those little at the end. And round to the nearest millionth. So those are some things that are going to come up as you are being asked to do some rounding. I apologize if I didn't bring up what Unit 3 is about. Unit 3 is not about fractions at all. Unit 3 is about decimals. And there's going to be a lot more easy things going on in Unit 3 with decimals than with fractions for various reasons. So part of our work on that begins with rounding a number like 12.637486 to the nearest tenth. Just like we did with rounding previously, I'm going to write down 2 answers, and we're going to talk about which one is correct. So it's either 12.6 or 12.7. To the hundredth, it's 12.63 or it's 12.64. Student had made a point of saying, can you write down which is which? The 6 is in the 10th place, the 3 is in the 100th place, the 7, 4, the 8, and the 6 are in different places. Okay? The next number, rounding to the nearest thousandth, would be 12.637 or 12.638. Notice every number on the right is a little bit bigger than the number on the left. The next one is 12.6374 or 12.6375. Then we have 12.63748 or 12.63749. And last we have 12.63746 or 12.6378447. Sorry, I kind of gummed that one up. Okay? So we're looking to round to a number and talk about how that's going to work. If I am rounding to the 10th place, I focus on the 6. The number after the 6 is a 3. I round it to this side if the number after it is 0, 1, 2, 3, or 4. I round it and put the answer from this side if the number after it is 5, 6, 7, 8, or 9. Because this is a 3, the correct answer is 12.6. The next one down says round to nearest hundredth. The number I'm focusing on is the 3. The number after the 3 is a 7, which means I round it up. As I go to the next number, 7, the number after that is a 4, which means I do not round it up. I look at the 4, the number after the 4 is an 8, I round it up. I look at the 8, the number after the 8 is a 6, so I round it up. And the reason I choose the smaller one in number 6 for millionths is there is nothing after the 6. I don't know what's after the 6. I can't tell. So if I can't tell, I can't round it either way. It must stay the same. Okay? Gonna pause this part for just a sec, and I want to get to our class work for that section so we can look at that. My computer's going slow. So if we went into the unit 2 and 3 work on our Canvas, and oh, you know what? I probably want to preview it. Well, I think I can skip around. Probably should be student view. Yeah. All right. This will work. If I can get to the next question. All right. So I'm just trying to think about whether I can do this or not. Oh, I can jump around here. Okay. So question 1, write a word name for the decimal. Question 2, write a word name for the decimal, etc. Question 3, write in decimal notation. So there's no fractions. You're just trying to write things down as decimals. Here is our first rounding question. Question number 5, round a number. Question number 6, round a number. Question number 7 and 8, I think, and maybe even 9. No, 8 is about a syringe. You need to look at the syringe and find the volume. If you look, it's between 0.8 and 0.9. So I'm trying to take an eyeball view of how that's going to work. Question 9 is a larger size syringe, so we can see that. Question number 10, bigger or smaller decimals? Question number 11, same thing. Question number 12. Okay, convert to a fraction. That's going to be some other stuff from the other side. I think there are same 32 questions going on here. I'm jumping to 24, maybe 21. Okay, here's 21. That's just a straight multiplication between two numbers, and you have a calculator. You should be able to type that into your calculator. You should be able to type that into your calculator without an issue. Okay, so a lot of the questions on this section are straightforward math questions. This one here is talking about subtraction. So you have a decimals and you have a calculator. It's just that straightforward to get those answers. Okay, the ones I want to talk about, I believe, started around question 10 or 11. Decimals of fraction, 12. Okay, so here I'm going back to the camera. We're going to look at some of the questions that are on the back of the paper that I just said, or the second paper if you have to make 2 copies. Okay, so the way we answer any one of these questions here is write a fraction as a decimal, is we actually do 3 divided by 10, or 17 divided by 20, or 5 divided by 8, and I'll tell you the rest, or 24 divided by 36, or 4 divided by 9. That's really what you do with your calculator. And when you do that, this comes out to be 0.3, and that's what you write down. This one comes out to be 0.68. This one over here comes out to be an interesting answer of 0.66666 repeating, which you can write as 0.06 with a line over it. And I believe when MyMathLab asked you about that, there might be a place for that line if the question, it actually makes sense to have that answer. The fours is 44444, okay, otherwise known as 0.4 with a line over it. Sorry, shouldn't be line over that. But the idea is that's also a repeating decimal. This one is going to be 3 point whatever that decimal is, which was 6, 2. So the 5/8 gives you 625, and then you stick the 3 in the front. So that's how you write a fraction as a decimal. As you move to decimal as a fraction, it's similar, but it's a little different. This answer is 22, and it's over 100 because it's in the hundredths place, 10th place, hundredths place. Okay? This isn't reduced until you divide both sides by 2 to get 11 over 50. One way of looking at that is that you have 2 times 11 and 2 times 50. Cross out the 2's. Okay? This one would be 48 over 1 with 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay? We're going to do 4 times 12 is 48, and 4 times 2,500 is 10,000. And then I'm going to chop those in half, and I'm going to have 6 and 1, 2, 5. So that would be the final answer. When you do this math, my math lab is going to want you to reduce each fraction. This one is going to be a big 6 and a 35 over 100. The big 6 stays the same, but 35 is 5 times 7, and 100 is 5 times 20. So we cross off that. It becomes 6 and 7 20ths. And this one here is 8 and 125 over 1 with 1, 2, 3, 4, 5 zeros. Okay? Now, the 8 stays. 25 goes into $1.25 5 times. 25 goes into that amount of numbers 4,000 times. Drop off those, and then we have, this is 5 times 1, this is 5 times 800, so that turns out to be 8 and 1/800. So there is an overlap of fractions and decimals, but it's a lot different. You don't need to worry about when you're adding or subtracting any common denominators and decimals. You don't need to worry about any of that. You have the calculator. You should be able to put it in and get the answers. Okay. The only other question that might come up is if you're talking about something called the unit price. And so if and when that comes up, we're going to do the 50/40 divided by 6. And I believe that came out to be $8.40. This is a divide by question. Okay. You have plenty of time to rewatch these videos before your work is due next Monday. You have lots of worksheets that I put out on fractions. I didn't put out as many on decimals because I don't think we're going to need that much time on decimals. If you have any other questions, you know how to get in touch with me with Ask Your Instructor or other things. And make sure you start thinking about the fact that in 2 weeks from last Tuesday on the 30th, you're going to be taking your first exam. So you might want to put a little extra time studying between now and then if you have finished these fractions early. Try also not to wait till 9 o'clock on Monday night to do it, because if you have any questions, I probably won't be answering emails at that point. Okay, thank you for checking in with the second video of part 2, and we will see you on next Tuesday virtually.